Today, I'm trying to repair a Yamaha home theater receiver.
Hello the internet, and welcome back or welcome to my channel. Today on the bench I have this Yamaha receiver. It's a Yamaha RX-V371. It's a home theater receiver. And I got it as faulty from a local seller, and apparently it doesn't power up. Let's take a quick look at the specifications of this device. I don't think it's a very expensive one. It's rated, the website says 100 watts, but it also says 1 kilohertz, 1 channel driven at basically 1% distortion, which means, realistically, are we looking at like 40, 50 watts maximum when you're actually using the unit? The nice thing of this unit is that it has HDMI inputs and it supports the HD formats like Dolby Through HD and DTS HD. So that's not bad. And looking at the back of the unit, nothing super fancy, but again, I have HDMI inputs and obviously an output. I have a standard 5.1 output. I don't have a 5.1 analog input. I don't have a 5.1 preamp output. So it's a very basic receiver, as you can see. It's just the bare minimum of what you could expect. Before we do anything, let's test the fuse. Let's make sure the fuse is okay. And the fuse is definitely okay. Okay, I'm going to plug the receiver into my current limiting device, which is the homemade one made with light bulbs, basically, just in case it decides to explode. So I got power to the receiver right now. It's powered now. Let's try and power up and see what happens. Okay, nothing happens. Perfect. And I guess the next step is to open it up and see what happens inside. And here we are inside the Yamaha. Now, I have found the schematic, so we can take a look in a minute, but I do see some similarities with Onkyo receivers. This little board here looks like where the mains power is going in. And then you have mains power going into the main transformer, and then you have output going somewhere else. And you can see there's a very small, let's call it auxiliary, or I would call it standby power supply. And there's a little cable going to another board. Now, from my understanding, the relay is basically normally open. So when you plug the receiver, what happens is the main transformer is not energized. But this small one, it is. This one is generating whatever low voltage is required for just the processor to be energized, or maybe part of the processor or part of the logic of the system. So when you push the on-off button at the front, there is some logic listening in the unit, and the logic will then return a signal to power up to energize the relay. The relay will feed mains power into the transformer. The transformer goes to some kind of power supply board where the main voltages are generated and the unit actually goes online. Just following the cables, I see that once the main transformer is getting mains power, I have two bunch of cables here coming out. One set is going to the board here at the bottom. This is probably the rail dedicated to the power transistors. So this is probably generating something like, plus or minus 50 volts or something like that, which is actually used for the power transistors. But then I see another bunch of cables, which is going to this little board here. You can see you have AC 2, 3, 4, and 5. So you have 4 AC circuits, and those are going to this board, and this board looks like I would call it a power supply board, because I have 1, 2, 3 bridge rectifiers, I have some capacitors, and maybe just behind these heat sinks, I have some voltage regulators. In here, I have a connector which says, you can barely see that, but PWR RY, power ready. For example, I have a 3.3 volts, which is probably the CPU power. I have a 5A, 5I, I don't know, but it looks like a 5 volts. Oh, and this little cable here, it's actually going back to the little board, which is actually powering the unit. But I would definitely focus on, is this board generating the voltages required to power up the unit? So first I need to check again, the thing doesn't even try to power up. So this is not my problem, I feel. But first, I would definitely make sure that we have the voltage coming to this board. And let's have a look at the schematics together.
Now, let's take a look at the schematics real quick. Please don't jump away. I will be quick, I promise. So this board you see here is the little board with the relay where the mains is coming in, AC is coming here. And as you can see, it feeds power to the main power transformer, which is not being used at the moment. It doesn't even try to power up, so I don't care about this. So let's continue here. You can see this one is the, I call it the standby transformer. There's some voltage coming out through some rectification. There is a signal coming back, which is called PRY. I think it's power on other connectors is power RY, power relay. This is the transistor which is energizing the coil of the relay, which energizes the main transformer. So there's nothing coming back, or at least it looks like there's nothing coming back from the signal, or there's a fault in here. The voltage S9 coming from this little board called operation 3 goes to operation 2, which is the board with all the capacitors and the bridge rectifiers. Now looking at this board here, S9 voltage coming from the operation 3 board comes into the operation 2 board through the little connector on the left hand side. And the S9, as you can see, goes to a plus 3.3, I think it's not sure whether it's a voltage regulator or anything. It's a component, IC131, which generates 3.3, which is actually called, if you follow the signal, it's called 3.3M. And if we go later on, when we look at the schematics, we will find that this 3.3M actually reaches the CPU itself. I would call it 3.3 volts standby, to be honest. I don't know what M stands for, but definitely that's it. Everything else, any other voltage, you can see there's a plus 5 volts here, there's a plus 12 here, there's another plus 5. They all come from, from bridge rectifiers and components, which come from this connector, which is the main power transformer. But the main power transformer is not being energized at this time. So honestly, all these are non-existent. The only voltage which exists at this moment when you just plug the unit is this 3.3M, which is present on the kind of large connector in the middle of the board.
And let's check the 3.3, which is 1, 2, 3, 4. 1, 2, 3, 4. Just go in here. 1, 2, 3, 4. Oops. And we have 3.3. Now, something I haven't mentioned is, you can't see from this angle, but this capacitor here is bulged. So I thought, well, maybe it's an easy thing, it's just a bulged capacitor. But it doesn't look like that. I do have voltage coming in. That's it. To be honest, when it's in standby, that's all that happens. Now, looking at the schematics here, I see the power button is basically going straight on this connector. And then you have PSW, power switch, I suppose. And you can see here the same board. And what I'm doing, I have the meter in continuity mode, but I'm basically probing the switch itself. It doesn't really go to 0 ohms, to a point where the thing doesn't even beep. Oh, there it is. I'm wondering whether it's just a faulty or a dodgy, actually, switch. So I'd be tempted to just disassemble that thing, and maybe, again, we don't have the Oxid in the UK. Sorry, Adrian, Digital Basement, but I have something similar I can try. Okay. It's a little better, but it's not... So let's give it a go, and if it still doesn't work, we'll try with the screwdriver. Okay, I've got power in. Let's try now. Nope. Let's try with a screwdriver. Nope. Nope. Okay, that's weird. Little step forward in here. Now I found that, so this board you can see here is this board here. And on the right hand side is where it's getting the power from the switch, and you can see it says PSW, power switch. Now obviously this is going through something, because here on the left I have PSW dead. So I guess this is the logic signal. So when the switch is pressed, there's some logic happening on this board, which is getting 3.35 volts. And there is a power switch detection, which is going to this board here, which is this board here, which the HDMI ports. You can see here on the top, you have all the HDMI ports. And here at the bottom, which is this kind of flipped over, so the HDMI ports are here, and that's the connector I'm talking about. On this connector here, I have the 3.35 volt, the 3.3 volts going to the front panel, and I also have the PSW detected. Now, I have measured 3.35 volts going to the board and reaching the board. Most importantly, if I'm looking at the power switch detected or detection on my multimeter, I see a 3.2 volts. Not anymore. You can more or less see a 3.2 volts here, and when I'm pushing the on-off button, it goes to ground. So the power button works, and it's definitely reaching the board, because I'm actually reading from the pin. So it must be something else, obviously. Okay, so let me recap of what we got so far. So we have mains voltage coming in. We have some kind of AC voltage coming out of this little board here. This AC voltage is powering a voltage regulator on this operation. It's called the operation board here. And we do have, I have 3.3 volts going to the processor. It's called 3.3M. Now the CPU somehow has 2 or even 3 voltages coming in. So you can see here we go VCC2, which is the same 3.3 volts M, and then you have this AVCC, which is still coming from 3.3 volts M, and finally, there you go, VCC1, there you go, VCC1, which is still coming from 3.3 volt M. I'm not entirely sure why the board has 3 different rails, 3 different supplies, but they all come from 3.3 volts M, which is the one that we've just seen that we have. So let's double check that the CPU has all these voltages. Okay, let's go and check all the rails. So VCC1 is pin 14. Okay, power up. And we have 3.2 volts on VCC1. Let's now check VCC2, which is pin 60. There we go. And we have 3.3 volts on pin 60, which is VCC2. And now let's check these AVCC, which is pin 97. And we do have 3.3 volts. Okay, so we do have the supplies. The next step I want to check is whether we have the clock on the CPU. Now, Yamaha drawings, I really like them, much more than the Onkyas. So there is a page here where you actually have some indication on how to measure, well, let's say the main signal, so the clocks at the reset line on the CPU itself, and then you have the clock on IC221, which is the CPU. So it tells you how to measure the clock on IC221, the clock on IC201, which is, I think is one of the DSPs, and the clock on IC261, which is, I need to check, one is a DSP, one I can't remember what it is, but to be honest, IC261 and 201, they are switched off while the receiver is standby, so there's no reason to check those two. But I want to check the clock, and I also want to check the reset line, and we'll get to that in a second. So let's check pin 11 of IC221. The crystal is here, I got 20 megahertz, and it says to check on pin 11. So let me check on pin 11 as the data sheet says, and I'm expecting 20 megahertz. So if I power up, There's a very nice 20 megahertz running. And I think I've noticed something that after a few seconds, the processor, the CPU switches itself off. In my mind, it's reasonable. These things are switched on all the time. So I guess they designed some sort of a deep sleep. First time when I tested it, I thought, well, maybe that's the problem. I don't know, to be honest. It still could be a problem, but I've noticed that if I try and turn it on, it comes back. That also tells me that the CPU is definitely getting the on-off button signal, is waking up, but somehow is refusing to wake up the rest of the equipment, which is a bit concerning because, you know, you're like, all right, is it something I can fix, or is there an EEPROM issue? Is there a software issue? Is there something corrupt, or why is the CPU is misbehaving like that? The next step would be to check whether we have a reset line. Now, looking at again, schematics are really helpful. There's a reset line called nReset, and a look in here is basically, if you look at this part here, what happens is the CPU is receiving 3.3 volts, which is the 3.3M coming from the operation board 2, which is that one with the voltage regulator, which gets the 3.3 volt standby. And then what happens, the nReset line goes high, just like, what is that? I don't know, by a few milliseconds after. So basically, it's just a reset line. So the CPU gets powered, and a few milliseconds later, it gets reset. And then it's when it starts processing. That's totally normal with any CPU, any chip, to be honest. So I would need to probe the 3.3 volts line and also the nReset line. Okay, so right now I've got channel 1, which is the yellow one. It's my 3.3 volts, and the magenta channel is the reset line. So you can clearly see the 3.3 volts goes up immediately, and the reset line basically goes completely high after about 1 second, because each one of these division is 500 milliseconds, so it's about 1 second delay. And that's fine. That's exactly what the schematic says. I thought that 1 second was the whole thing, but no, actually it's exactly like that. 1 second later, the CPU is resetting. I completely appreciate that I'm actually checking here on this connector. Now, I know 3.3 volts is reaching the CPU, but I don't know whether the reset is getting to the CPU. So let's do this again, but this time probing the CPU reset line on the CPU itself. Single again, and go. Yeah, as you can see, it's the same thing. 3.3 volts is starting straight away, and the reset line is happening after 1 second. So we know the reset line is working. I'm a bit running out of options here. We know the CPU is doing something, because when I'm pushing the on-off button, it's kind of turning on and off the clock. Did we check whether we have the on-off button at the CPU itself? We can check it now, since I have everything connected. Okay. So if I'm pushing the on-off button, it's going low, up, high, low, high, low. So this is reaching the CPU as well. So again, we have voltage, we have clock, we have reset, we have the power switch, but the CPU is not sending out the power relay, which is pin power relay. There we go, pin 84. Okay, and if I'm trying switching it on, there's nothing coming out. So this means the CPU somehow is basically saying, no, I don't want to switch it on. Why? That's a bit complicated to find out. One thing I want to try is to take a look, I think, at this little chip here, which, if I'm not mistaken, is the EEPROM. I want to make sure the EEPROM is powered, and maybe inspect some data lines, you know, see if is there any activity in between the CPU and the EEPROM. Let me start with the supply. Okay, so we have 3.3 volts as a supply. Let's check pin number 6. Okay. So if I'm zooming in here, yeah, there is definitely some data happening. This is good news, because to me, that means the CPU is running something, is trying to do something, so it's not completely dead. But now, honestly, I'm running out of ideas, because again, we got power, we got clock, we got the reset line, we got data coming out of the CPU, we got the EEPROM that seems to be running. Honestly, at this point, it feels like maybe the EEPROM is corrupted, and that's why the CPU is running that quick code, and then it stops because there's some kind of code corruption or some malfunction somewhere, and it just stops, unfortunately, with no way to know what's wrong with this. One thing I would like to try is to see whether there's any way to reset the unit. Sometimes you just, you power it on, or you plug the unit while holding a button, and again, I have no idea whether maybe the CPU's got stuck into something, and maybe there's a hardware reset or some kind of service mode or whatever. And the manual is actually pretty comprehensive. There's a self-diagnostic function, and there's a very, very comprehensive explanation about it. And to get into self-diagnostic, you hold tone, control, and straight while turning on the unit. So let's try that. You never know. It's very unlikely, I'd say, because again, it looks pretty dead to me, but let's try it. So again, this thing is not working, and I'm trying with tone control and straight. Whoa, it's working. It's got into the service mode, so it's not completely dead. Wow, I wasn't expecting that. And what happens if I switch it off? Does it switch on now? It does. So what was that? Did it get stuck somewhere into a kind of a limbo for whatever reason? Oh, this is completely switched off by itself. Now, looking into the self-diagnostic mode, I've actually noticed that when it powers on in the diagnostic mode, the opening message is the last error message that happened on the unit. So if it's all okay, it says no protect. Otherwise, it will give other PS protect, which is power rail issues, or there's a I protect, which is basically current being output at the speaker terminal, DC protect when you have DC at the output, PRV was that voltage in the power supply section. So let's try to get back before powering back again, because I guess that will if it powers up, it may reset the thing. Let's go back to the service mode, and let's take a look at what's the first error message that says, if there is one. PSPRT 095L. PSPRT, it says an excessive... Oh, and it's switched off again. So the error message is PS, which seems to suggest that there is a problem with the power amplifier. It says a current of the power amplifier, as current of the power amplifier is detected, the abnormal channel can be identified by checking the current detect transistor. Right, this is switched off. I haven't got much time because it seems to be switching off all the time, which is a good point. It looks like it's a supply issue maybe, or one of the power amplifiers has failed. But I can see here on the manual, there's a protection history. So let's try and check protection history very quickly. Okay. 21. PS1. We have PS1, 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 PS1. They're all PS1. Oh, there's an interesting mention here. Applying the power to this unit without correcting the anomaly can be dangerous. Okay. To avoid this, if PS and DC protection function works 3 times consecutively, the power will not turn on even when the power button key is pressed. In order to turn on the power again, disconnect the power cable of this unit from the AC outlet and then reconnect it again. I mean, it looks like they may have changed this behavior. Now, the service manual seems to suggest a problem with the amplifier, but at this point, considering it's powering off again as well and everything, I want to look into that bulged capacitor, which maybe you can see from here. Not much, but it's this one. It's slightly bulged. I want to see what it's doing. So the capacitor in question should be C1320. And I see that C1320 is indeed getting power from the main transformer. AC is going through a bridge rectifier, and then it's going through that single capacitor. From there, it's actually going to something which is called plus 7D. So that's not 12 volts or minus 12 volts, this is 7D. And what is 7D going to do? So here we go, 7D coming in, and it looks like it's actually a very critical voltage, because 7 volt is then used for 5 volts HDMI, 5D, 3.3D and 1.2D. And from what I can see, if looking at schematics, these are basically the voltages which are going to the electronics when the unit is waking up. So remember, we have 3.3M, which is coming from this connector here. This is always there. As soon as you plug the unit, you got 3.35M. Let's call it standby, and it's going to the CPU, more or less to the CPU only, and a few bits and bobs. But the 7 volt is coming through this cable, this connector, and you have these 2 voltage regulators, probably it's more than 2, 1, 2, and probably 3 here, which are making the 5 volts for the HDMI, but also 1.2, 3.3, and 5 volts for the rest of the ICs on this board. So that's actually a critical voltage. Let's have a look what's coming out of these 7 volts after this bulge capacitor. Oh wow. Look at how ripple, the massive ripple of this thing. Each division is 2 volts. There are 4 volts ripple. I'm not surprised that there is an issue with this receiver. Now let's have a look what we have as output for the electronics. So let's check the 3.3D. It's kind of working now. So now I'm checking again the output of 3.3D. I think. Let's power up. It's not so bad for now. It's pretty stable and linear. Oh, you see the ripple coming? Let's try again. Oh, look. Oh yeah, you can see the voltage is definitely unstable. There you go. There you go. It's jumping. It just switches off. I have a feeling, I know it says there's an amplifier issue, but again, to be honest, this voltage shouldn't be like that. I will definitely go ahead and replace the capacitor, and then I will check again this voltage and see whether this voltage is coming back okay or not.
And a few days have passed, and I've got the capacitors. So I'm going to replace it. And silly me, all the videos I've been publishing over the past months, I never realized, or actually I forgot because I knew about that my oscilloscope has a web interface. So I didn't need to point the camera at the oscilloscope itself. I have a very fancy and very functional, apparently, web interface with the oscilloscope itself. So sorry for that. Well, let's switch it off and let's go ahead, replace the capacitor, and then we'll check what happens later on with the capacitor replaced. And here is the board. I think it's called the Operation or Operations 2 board. You can see here the bulge capacitor. It doesn't look so bad, to be honest. Obviously it shouldn't be bulged, so fair enough, but it's a Jamicon. Apparently, looking online, this is a known issue with these models of Yamaha receivers. Interesting. These should all be more or less, that's a 7912 for minus 12, 7812 for plus 12, a voltage regulator, plus 5, actually, yes, 2 7805 for plus 5s, and that I don't know, to be honest. It actually doesn't look in terrible shape, to be honest. it's bulged, but I don't see leakage at the bottom. So let's test it. Oh well. Yes, fair enough. It doesn't even see it as a capacitor, to be honest. Okay, that may explain the behavior of the unit. As a reference, let's test one of these brand new capacitors that I purchased, which are Nikon PW series. Not exactly the ones I wanted, but 10,000 microfarads are not easy to find, to be honest. It says 10 was the millifarad, so I'm assuming that's correct. Anyways, it definitely sees it as a capacitor and not as two diodes. So yeah, this is definitely faulty. Now, since I'm here and I've got the desoldering gun switched on, it should take me only a few minutes just to check these other three capacitors. 4,700, this is 4,700, ESR is pretty low and it is working perfectly. And this is a 2,200, it says 1,900, is still within 20%, ESR is pretty low, so this is good as well. And this is supposed to be a 4,700, 20% would be 3,700. So this is within parameters, and this can go back. There we go. All is done, so now it's just a matter of putting it back, replace the thermal paste and give it a test. Since we have now removed this board which covered the actual amplifiers, I wanted to show you the monolithic amplifiers this device is featuring, which are labeled STK433. These are, I would say, they're pretty bad. This is just, again, monolithic amplifier. I think there are 3 channels each. I believe these are 3 channels because I have another one from Onkyo which is also powering the subwoofer. So it's only going to be 5 outputs. Yeah, subwoofer is RCA. Probably 1 channel is not being used. Again, from what I know, from my limited understanding, these are basic devices. Okay, everything is back as it was, and I have plugged the oscilloscope back so we can check the report with the new capacitor. So let's give it a go. 3, 2, 1, go. And the ripple is more or less non-existent. It's absolutely amazing. I mean, the ripple is, what is it? Some of this noise is my Wi-Fi, power line Wi-Fi, but again, one division is now 200 millivolts. This is more or less 200 millivolts. From 4 volts to 200 millivolts. That's interesting. So now the reading is 8.27 volts RMS, which I think is what it's expecting. I've got this little icons here, which mean the output should be connected. So let's plug a speaker and see if it's working. And the speaker is plugged in, so let's power it up and see if it's working. And it is working, and honestly, there's no questions why it's working. I mean, the ripple on the 7 volt line was obviously, well, the capacitor clearly had completely stopped working. And again, it looks like this particular capacitor is a common fault with this type of receivers, which I didn't know, by the way, when I started working on it. Before I finish this video, I want to test the unit, I'd like to do two tests. One is to make sure that all channels are working, and one is to push, let's say, left and right channels with a dummy load and checking with the oscilloscope that power gets to a reasonable level and make sure the unit is not shutting down or, you know, anything unexpected happens. Now, for testing all the channels, I've noticed there is a very nice feature in the service menu actually. Is this test all. Right now the unit is outputting kind of band limited pink noise out of all channels, so let's go and check it. Here we are. I'm just again quickly checking with my speaker all channels. Is this left channel? That's fine. Right channel, center channel, left surround, and right surround. And here is the subwoofer channel. You can't really hear it, but it's working. I mean, this is not a subwoofer, it's a mid-range. But there's definitely some output. It's very low, but there is some output. And here I've got some 100 watts 8 ohm resistors. I connected one resistor to each of the channel, but the left channel, which is connected to the speaker. And for my final test, I have my signal generator, which is set to 1 kilohertz, around 1 kilohertz, it's around here. And the output of the signal generator is going to the aux input on the Yamaha. The Yamaha is set to aux, and I currently have some signal coming out. So what I'm going to do now, I'm going to replace the speaker with another resistor, 8 ohm resistor, and connect an oscilloscope, monitor the output, see what the voltage is when I'm pushing the unit a bit, and then I guess we can call it a day. What I'm going to do now, I'm going to, see what kind of power we're getting. I don't want to push this amplifier too much. I'm sure it's going to protect itself. I don't want to push my luck. It's definitely not a high-end amplifier designed to run powerful signals. So what I'm going to do, I'm going to, see what kind of voltage is coming out, try to reach the clipping point, try and record and measure. You can see on the oscilloscope, I've got the statistics on. So I have the RMS of channel 1 set for recording the minimum and the maximum. You can see if I'm turning this up, it's now recording a maximum of 394 volts. So I'm gonna increase it slowly, but also fast. Again, I don't wanna push this thing too much until it clips and see what it records as a maximum output. So turn it up now. There it is, where it's clipping. And it's recording at 27 volts. That means that I should be able to calculate using Ohm's law the power, and again, given the 27.1 volts and the 8 ohm resistance, I'm reading something around 95 watts, which is pretty impressive because, again, remember that I now have not all channels. I think in this mode it's only left and right. So it's left and right channels basically running at maximum power, and I feel it's pretty impressive for a very basic machine like this. Well, the unit is working now, and I guess I will just do a few more checks, like making sure that all the HDMI ports are working, let it run for a while just to avoid nasty surprises, and then hopefully I will find a new home for it. I hope you enjoyed the video. I know eventually was an easy fix. I could have replaced that capacitor straight away, but well, where's the fun in doing that? I totally enjoyed going through all the diagnostic steps with you. I hope you enjoyed that too, and I hope to see you soon on my channel again. For now, you have a great day, and I'll see you soon.